Okay, so this is section 6, chapter 6, section 4, graphs of the sine and cosine functions. Super exciting. So just to recall, we're going to write our functions as either y equals sine x or f of x equals sine x, cosine x, tan x, cosecant x, secant x, and cotangent x. If we were to look at sine, we have our radians here: 0, pi over 6, pi over 2, 5 pi over 6 pi, 7 pi over 6, 3 pi over 2, 11 pi over 6, and 2 pi. We picked these values because they are either 1/2, 1, 0, or -1, so it's easier for us to graph. So when you make a sine or cosine function, you want to split up your graph, usually in increments of pi and 2 pi. And then I go back in halfway between 0 and pi, I put a pi over 2. Halfway between pi and 2 pi, I put a 3 pi over 2. So when you graph that, 0, 0, pi over 6, 1/2, pi over 2, 1, 5 pi over 6, 1/2, and pi 0, 7 pi over 6, -1/2, 3 pi over 2, -1, 11 pi over 6, -2, and 2 pi 0. So this is the function sine of x for values that are between 0 and 2 pi. So when you have the function y equals sine x between negative infinity and infinity, that graph repeats and carries on all the way left and all the way right. So if you recall from the last section, the domain is the set of all real numbers. So we can input any real number into the sine function. The range is going to be from -1 to 1, with those values being included. The sine function is an odd function. So if you look, it's got symmetry about the origin. And we studied in the last section that when we put in negative x, we get out negative sine x. The sine function is periodic. The period is 2 pi, so that means from where we start, we hit 2 pi, and then we start over with the cycle again. The x-intercepts are -2 pi, -pi, 0, pi, 2 pi, 3 pi, or any pi with an integer multiple. And the y-intercept is 0. The maximum value is 1, and it occurs at all our pi over 2 so like at 3, so -3 pi over 2, boop, at pi over 2, 5 pi over 2, 9 pi over 2. And the minimum occurs at -1, and that happens at -pi over 2, 3 pi over 2, 7 pi over 2, 11 pi over 2. Every other odd. I guess is how we'd say that. All right. So now we're going to start fussing with the sine equation. It's going to be great. So we're going to have y equals a sine omega x. So if we want to graph y equals 3 sine x using transformation, 3 is buddies with this a. A represents amplitude. And I think of amplitude as how far we turn this function up. So normally our function goes to 1. If we are going to multiply it by 3, it's going to take each of these max and each of these mins and spread them all the way up to 3. So we're going to get a really tall wave here. a really low trough here. And it's going to have a vertical stretch of 3. So here, negative sine 2x, we're going to use transformation. This negative means that we are going to reflect it about the x-axis. So what was up here at pi over 2, 1 is now going to be down here at pi over 2, negative 1. What was down here is now going to be up here, and that's reflected negative. The 2x is going to be a horizontal compression by a factor of whatever the reciprocal of 2 is. And in this case, it's 1/2. So horizontal compression by a factor of 1/2. So what I do is, instead of changing my graph, my sine wave, I change the way I count on the x-axis. I know it sounds crazy. But instead of redrawing the entire graph, I just relabel this. Instead of pi over 2, I'm going to multiply each of these increments by 1/2. So instead of getting to negative 1 at pi over 2, it's going to shrink that closer to the x-axis and get it to negative 1 by pi over 4. So if you go pi over 2 times 1/2, that's pi over 4. Pi times 1/2, that's pi over 2. So you're still matching the graph with the coordinates, but I find it easier to just change the way I count on my graph. With the original function, your period is 2 pi. We're going to compress it by a factor of 1/2, so my period is going to be pi. All right, so let's take a look at the cosine. The cosine starts at 1, goes down and hits the x-axis at pi over 2. It has its trough or its minimum point at pi comma negative 1, and then starts building back up, crosses at 3 pi over 2, and then comes here and has its max at 2 pi comma 1. And this is the graph of cosine x between 0 and 2 pi. Between negative infinity and infinity, that pattern continues on. The domain is a set of all real numbers. You can put any real number into the cosine function. The range is from negative 1 to 1. The most it'll go is 1, and the smallest it'll go is negative 1. Cosine is an even function. It has symmetry across the y-axis. This point here, symmetric with this point here. So if I put in a negative pi for an input, it'll get me out negative 1, which is the same as if I put in pi. The cosine function is periodic. Its period is 2 pi. Its x-intercepts happen at negative 3 pi over 2, negative pi over 2, pi over 2, 3 pi over 2, and 5 pi over 2. The y-intercept happens at 1. Maximum values of 1 occur at negative 2 pi, 0, 2 pi, 4 pi, 6 pi. So we're counting up by even pi's. And then the minimum value occurs at integer amounts of pi. So negative pi, pi, 3 pi, 5 pi. So the odd values of pi. All right, so we're going to check out how amplitude and shift, or not shift, but amplitude and vertical stretch or compress affect the cosine function. So if I have y equals 2 cosine of 3x, the 2 is going to raise these up taller. So instead of negative 1, it's going to be negative 2. Instead of positive 1, it's going to be positive 2. So make that taller. And the 3 inside the function is going to vertically compress it by a factor of 1/3. So each of these coordinates is going to get multiplied by 1/3. So instead of crossing at pi over 2, it's going to be pi over 2 times 1/3, which is pi over 6. Instead of experiencing this min at pi, it's going to experience it at pi over 3. Instead of hitting this peak at 2 pi, it's going to hit it at 2 pi over 3. So each of these events happens now at whatever our x coordinate is times 1/3. So these are a couple sinusoidal graphs. The pink one is a classic cosine function. If I want to shift it pi over 2 units to the right, so I'm taking this maximum and I'm shifting it to pi over 2, so I'm moving my whole graph pi over 2 units to the right. It keeps everything the same, and I'm just now moving the cosine. If you look, y equals sine of x is the same graph as this blue one here. So if I shift cosine over to the right pi over 2, I'm going to get a sine. So that is the identity. Sine x equals cosine of x minus pi over 2. It's a property, so let's highlight it, make note. So when we graph these two, sine of x and cosine of x minus pi over 2, we only see one graph because these guys are right on top of each other, same graph. So we're going to look at and determine the amplitude and period of sinusoidal functions. So if I have y equals cosine x, if I want a vertical stretch by a factor of 2, I multiply it by 2, and that raises up the graph from 1 to 2 at my maximums. The definition of amplitude is that it is the number we are multiplying by when we look at our function. So it is the distance from 0 to the top of my graph, to the maximum point of my graph. That is the amplitude. If I look at cosine, if I want to have a compression, I replace the x with 3x, and I will get to this coordinate here 3 times as fast, pi over 3, by pi over 3 instead of by pi. Same thing with where I cross the x-axis. The normal cosine wave gets there at pi over 2. My new cosine wave with a vertical compression of 1/3 is going to get there by pi over 6. So you take the reciprocal of what's in here and multiply it by your x coordinate to find the vertical compression coordinate. All right, so the period is 2 pi divided by whatever is being multiplied inside your function. So make sure we box and highlight this. The amplitude is the absolute value of the distance from 0 to the max, or the number that's on the outside of your function. And the period, noted by a t, is going to be 2 pi divided by w. All right, so we're going to find the amplitude and period of the sine function. So y, a sinusoidal function, y is equal to negative 4 cosine 3x. We can already tell that the amplitude is going to be 4. It's just the absolute value of this number here. And then we know that the period is going to be 2 pi divided by 3. So instead of getting through one cosine cycle by 2 pi, we're going to get there by 2 pi over 3. Okay, so when you graph a sine or a cosine function, there are going to be special points you want to make sure you hit on your graph. Like zeros, for sine it would be 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi. By putting those coordinates on your graph, you can quickly graph yourself a sine function. For cosine, because it is, I think of cosine as the quirky function, it starts up here at 1. Sine, he's more of the normal guy. He starts at 0, 0. So I remember sine is 0, 0. He goes up and then down. Cosine is the quirky one. He starts at 1 and goes down. Hits here at pi over 2, 0. Then has its trough at pi negative 1, 3 pi over 2, 0, and 2 pi 1. So make sure you're hitting these coordinates when you create a sine wave. And hitting these coordinates for when you're creating a cosine wave. Okay, so if I were to graph these, we're going to use those key points. So if we know our amplitude is 4, and our period, we're going to get through our cosine wave by pi. The amplitude is four, and we want to go in, we want to take our period and divide it into 4 equal segments, because back here, we look, here we had 1, 2, 3, 4 equal segments. So when we go to do, even though we have a compression, we're going to take our period and divide it into 4 segments. So we're going to count by pi over 4s. So when we're going to have 0 pi over 4, pi over 4, pi over 2, pi over 2 is 3 pi over 4, and 3 pi over 4 are pi. So on my chart, I'm going to go pi over 4, pi over 2, 3 pi over 4, and pi. And there we're going to be, these are the important increments. At 0, the cosine is going to be 4. So our normal coordinates were 0, 1, pi over 2, 0, but remember we are compressing by a factor of 2, so instead of pi over 2, it's going to be pi over 4, 0. And it was pi negative 1, but now we're compressing that by a factor of 2, so it's going to be pi over 2 negative 4. It was 3 pi over 2, 0, but now it's going to be 3 pi over 4, 0. And then the last coordinate was going to be 2 pi as our period, but we have a compression of 1/2, so the 2 pi becomes pi. So then we pull out those points. So we start at 4. We can see our amplitude is 4. We go through pi over 4. We hit our trough at pi over 2, 3 pi over 4, and 0. My trick is I just have so normally I put the tick marks. I say this would normally be 2 pi, but because I have a 2 here, it's going to cut that into half. So 2 pi divided by 2 is pi. 3 pi over 2 divided by 2 is 3 pi over 4. So if we carry on this pattern, we get a nice graph. All right, so our summary is whether it's a sine omega x or a cosine omega x, we are going to use our key points. We're going to divide our interval, whatever our omega is. We're going to start with 2 pi and divide it by omega and create 4 intervals. And then we're going to plot those key points and draw the graph. All right, so let's look at here. I know my amplitude is going to be 3, and I'm going to divide by pi over 4. So my period is going to be 8. So instead of having, so let me show you on my end what this is going to look like. So here's a little bit of how it's not cheating, but it's kind of cheating. This is a little bit of how I get through. Okay, so hold on. So I'm going to erase that. So if you have your graph, and I always go 4 increments. 2, 3, 4. And I always have, here's the, we are graphing -3 cosine pi over 4x. So we're graphing a cosine. So if we're graphing a cosine, cosine normally starts up here at 1, 0. I'll make it in green. It hits here at, this is usually pi over 2. It comes down, hits at -1, goes back through there, and hits here. So cosine function normally looks like this. This gets a little bit more shiny. Okay. And so normally this would be 2 pi. But we, instead of having 2 pi, we went and it's going to be, from our calculation, it's going to be 8. So our new period goes from 2 pi to 8. So I'm going to change my period. Instead of being 2 pi, it's going to be 8. And then if I look here, here is the halfway mark between 0 and 8. What is halfway between 0 and 8? 4. And this mark right here is halfway between 0 and 4. Which value is that? 2. This mark here is halfway between 4 and 8, and that would be 6. Normally this would be 1 and -1, but my amplitude has changed. My amplitude is 3, so instead of being 1 and -1, this is going to be 3 and -3. And so now I have, by changing, not by changing the graph of the cosine, but by changing my scale, I can create a sine function. Okay, so let's go back to the presentation. So we divide it into 4 increments. I like to do it with a picture. My recommendation is draw the picture first, then you can look at the increments. So we cycle through, although it's negative. Oh my goodness. So that was my mistake here. We have to reflect it because it is a negative amplitude. So it just is going to be this red one here. -3 cosine. What was it? Pi over 4. Yeah. Okay. So because it's negative, it reflects it across the x-axis. So we start down at -3, go up, down, up. All right, we're going to do the same thing with the sine function. Its amplitude is 5, and we are going to increase the period. So the period was going to be 2 pi. We are actually going to cycle everything through by pi over 6. Oh, sorry, pi over 3. 2 pi over 3. We're going to divide 2 pi by 3. So we're going to cut this into 4 different increments. So we're going to go increments of pi over 6 because 2 pi over 3 times 1/4 is pi over 6. So that means that we're going to go, and it's a sine wave, so it starts at 0. It's positive, so we're going to go up first. Instead of going to 1, we're going to go to 5. Instead of hitting there at pi over 2, we're going to hit it at pi over 6. Come down, rotate through, hit here by 2 pi over 3. All right, so now we're going to look at that graph and find the function for it. So we're going to start with we know that this is a cosine because we don't start at the origin. So we're going to start with our a cosine omega x. We know our amplitude is 3. And we know our period, 2 pi over omega equals 1. So if we solve for omega, so multiply both sides by omega, and we get omega equals 2 pi. So in here, we're going to put 2 pi. So our function is 3 cosine 2 pi x. All right, let's look at this equation. So I go through the origin on this equation, so we know we're going to use sine. And instead of going through the origin and moving up, we go and move down. So I know this is a negative amplitude of 2. So I'm going to replace a with negative 2. And now my period, so we go, when do we get through? Oh, so my period is 4. So 2 divided by omega equals 4. Multiply both sides by w, divide by 4, and we get omega is pi over 2. We're going to go ahead and fill those in, and we get negative sine pi over 2x. And that's it for today. Thank you guys.